Okay, good day. This is Math 130 Intro to Statistics. I'm Professor McCauley. This is Lesson 22 Intro to Hypothesis Testing. Let's get to it. So, today we are going to talk about what is hypothesis testing, and we're going to state a null hypothesis and an alternative hypothesis. We're going to identify type 1 and type 2 errors. We're going to determine how to use a one-tailed or two-tailed statistical test to find a p-value, and then we're going to make and interpret a decision based on the results of statistical tests and write a claim for a hypothesis test. So this lesson here is an introduction, and so this is going to kind of set up the framework for the next 2 or 3 lessons that we do. So today's stuff is going to be a lot about me talking and kind of writing some things and showing you some things and going over the steps. There's not going to be a whole lot of calculation, but this process that we're setting up in this lesson is going to be used as we move forward. So let's start off with a couple definitions. And so first, a hypothesis test is a process that uses sample statistics to test a claim about a value of a population parameter. Okay, so at the beginning of this class, we talked about how definitions were important. And if you make a definition, future terms are based on those previous definitions. And so this hypothesis test, we already have a number of previously defined terms from this class. So a hypothesis test uses a sample statistic. A sample statistic is something that you calculate from a sample to make a claim about the population parameter. So we could have a sample mean to make a claim about a population mean. We could have a sample standard deviation to make a claim about the population standard deviation. So what is this? How is this used in the quote-unquote real world? So let's talk of an example. An inventor wants you to invest in their car company, claiming that their new engine gets a mean gas mileage of 75 miles to the gallon. If you think that that is an outrageous and false claim, how would you go about testing it? All right, so it would be difficult for us to test all of the engines in the world. So let's say, for instance, we sampled 50 engines, and we found that the sample mean was 72.3 miles per gallon, with a standard deviation of sample standard deviation of S equal to 6.8 miles per gallon. So on the surface, we would say, hey, maybe our sample was just low because the standard deviation is 8 miles or 8 gallons or 8 miles per gallon, 6.8 miles per gallon. So that encompasses 75 miles. Maybe our sample was just a low sample. Our sample mean was just a low sample mean. Well, we can test the probability that we would get a sample mean of 72.3 with a standard deviation of 6.8 if we said that the population mean was 75 miles in a gallon, because we've already done that. So for the sake of argument, let's assume that the statement is true. Let's examine the sampling distribution. So if we assume the engines have a mean miles per gallon, so our population mean is 75 and a standard deviation is 6.8. The central limit theorem, and then we got this from lesson 17, states that the standard error of that thing would be 0.975. So that there are so what that means is that our sample mean is more than 2 standard errors away from the proposed population mean. Or we could use something like a normal CDF where we go, what is the probability from negative 10,000 to 72.3, where the mean is 75 and the standard error is 9.758, we end up with 0.002829, or a 0.2829% chance of us getting that sample if the actual mean is 75. Either way, our sample mean is a very unusual occurrence, and we should be very skeptical of the investor's claim. So this gets us an idea of how we're going to start going about formally doing hypothesis testing. The first thing that we're going to do is we're going to claim or write a null hypothesis, and this is called H sub 0. It's a statistical hypothesis that contains a statement of equality, such as equal to, greater than or equal to, or less than or equal to. An alternative hypothesis, sometimes labeled H sub 1, but most often labeled H sub A, is the complement of the null hypothesis, and it is a statement that must be true if H sub 0 is false. So if H sub 0 is false, H sub A must encompass everything else, and it contains a statement of strict inequality, such as not equal to, greater than, or less than. So some notes about writing null and alternative hypothesis. First, we're going to translate the claim made about the population parameter into a mathematical statement. Then we're going to write the complement of the claim as a mathematical statement. And then the null hypothesis is a statement of equality and for testing purposes assumed to be true. The remaining statement is to be the alternative hypothesis. As a result, a claim can be either a null hypothesis or the alternative hypothesis, especially if the claim does not include strict equality. All right, so some examples. Coach McCulley publicizes that the proportion of his swimmers who are on the honor roll is 73%. Let's talk about a null, and so for number one, our null hypothesis and our alternative hypothesis. All right, so this is a proportion. So our on the honor roll is 73%. So for this first one, we're going to say that the proportion is equal to 0.73. And we are going to say that the alternative hypothesis is the complement of this thing. So our proportion of swimmers is not equal to 0.73. And in this particular instance, the claim is in the null hypothesis. Number two, a barbershop claims that the average wait time for a haircut is less than 10 minutes. So H sub 0, and we'll go H sub 1 for this one, just to show that there are a couple ways you can write your alternative hypothesis. But if we read this, a barbershop claims that the average wait time for a haircut is less than 10 minutes. There's no equality in this thing. So in this particular instance, this is an inequality statement. So the average, so the mean, the population mean, is less than 10. And then the complement of that is the mean is greater than or equal to 10. And in this particular instance, our claim is in the alternative hypothesis. All right? So a bakery claims that the average shelf life of its cream-filled yellow sponge cakes is longer than 3 years. You might notice a similarity to a national brand cream-filled yellow sponge cake. Don't want to break a copyright rule, so we'll leave that alone. So number two, again, or this is number three, sorry. Number three, the average shelf life. So we're talking about a mean. H sub 0, H sub A. We're talking about a mean. Is longer than 3 years. So again, greater than 3 years, that is inequality. So we're going to put that in the alternative hypothesis. Greater than 3, and that is our claim. And so our null hypothesis would be the mean is less than or equal to to 3 years. And so that's how we're going to start writing them. Types of errors in testing. What happens when we are wrong? Well, a type 1 error occurs if the null hypothesis is rejected when it is true, and a type 2 error occurs if the null hypothesis is not rejected when it's false. So just kind of a little table here. If we're talking about the truth of the null hypothesis, so in this statement, the null hypothesis is true. In this statement, the null hypothesis is false. If we reject the null or do not reject the null hypothesis, and it's true, then we made the correct answer. But if we reject a null hypothesis that is true, we will get a type 1 error. Now, if the null hypothesis is false and we do not reject it, then we made a type 2 error. If we reject the null hypothesis and it's false, then we've made the correct decision. Now again, type 1 and type 2 does not depend on where the claim is. It depends on the null hypothesis only, whether we reject a true null hypothesis or fail to reject a false hypothesis. All right. The type of error is important depending on the claim. So let's talk about a claim. A bulletproof vest company claims that their vests fail in less than 1% of shootings. So this is quite literally life or death situation. So making an error is important. So if I want to tell me which type of error is more serious, we should first talk about what's going on. So again, let's state the null and alternative hypothesis. A bulletproof vest claims that their vests fail in less than 1% of the shootings. So H, the null hypothesis, and we'll put a 1 there to do an alternative hypothesis like that. And so less than, that's inequality. So we're going to say that that's a proportion. So P less than 0.01, and that's where our claim is at. Let's spell it right though. Come on, Macaulay. Proportion less than 0.01. That is where our claim is. And so our null hypothesis includes equality, would be greater than 0.01. And so what are the possible type 1 and type 2 errors? Why did I do that? Let's put a point there. There we go. So our type 1 error, and again, type 1, we're going to reject a true hypothesis. Okay, so we would, let's go back to here. We would reject a true null hypothesis and so we would reject the statement that vests fail in more than 1% of the shootings when it is true. In our type 2, we would fail to reject the statement that vests fail in more than 1% of shootings. is false. All right. So, number 3, which is the more serious error? Well, since this is life or death, if the actual proportion is more than 1%, if the actual proportion is more than 1%, we want to know that. So rejecting a true null hypothesis, if we reject a statement that says that the proportion is more than 1%, we'll have more deaths. So clearly, if vests fail at a rate greater than 1%, we will want to know that. So, not Sal, so a type 1 error is more serious in this case, even though it is not the claim. All right, moving on. That was a long part. Level of significance. The null hypothesis is rejected when the sample statistic from a sampling distribution is unusual. Depending on the type of error, unusual events are often required to have a probability of less than 0.1, 0.05, or 0.01. If rejecting a true hypothesis is an error that needs to be avoided, then lowering the level of significance can reduce this type of error. So definition. In a hypothesis test, the level of significance is the maximum allowable probability of making a type 1 error. This is denoted by alpha, lowercase Greek alpha. The probability of a type 2 error is denoted by beta, the lowercase Greek letter. It is the complement of alpha, so if you're going to use an alpha of 0.1, your beta would be 0.9. Statistical tests and p-values, and so we can quite literally call a p-value a probability value. After creating a null and alternative hypothesis, then creating a level of significance of a sample statistic calculated. And so our sample statistics are sample mean, sample proportion, point estimate for that one, or the sample variance for a corresponding parameter, population mean, population parameter, population variance. This test statistic is standardized with one of 3 scores, a z-score, a t-score, or a chi-square scored. And so we're not doing chi-squared, and used in making a decision process about the null hypothesis. And so if the null hypothesis is true, then a p-value or probability value of a hypothesis test is the probability of obtaining a sample statistic with a value as extreme or more extreme than the one determined by the sample statistic. Moving on. Decision rule for a p-value. To use a p-value to make a decision in a hypothesis test, you compare the p-value with alpha. If the p-value is less than alpha, we're going to reject h sub 0. If the p-value is greater than alpha, we're going to fail to reject the null hypothesis. And so as a mnemonic device, if the p is low, the null must go, which means we're rejecting it. And if the p is high, then the null must fly. Fly meaning we're going to let it go by. So notes, the null hypothesis is either rejected or fails to be rejected. It is neither proven nor is it supported. And so if the claim is in the alternative hypothesis, it is either supported or not supported. It is never rejected. As an example, you perform a hypothesis test for the claim of how you should interpret your decision. Either reject the null hypothesis or fail to reject the null hypothesis. A realtor publicizes, excuse me, a realtor publicizes that the proportion of homeowners that are happy with the size of their home is less than 30%. So my claim is in the alternative hypothesis piece. The proportion is less than 30 are happy with the size of their home. All right. So in part one, if we reject the null hypothesis, we would say there is statistical evidence to support the claim that the proportion of homeowners sorry, use the same terminology, that are happy with the size of their home is less than 30%. And if we fail to reject, we would say there is not enough evidence to support the claim that less than 30% of homeowners are happy with the size of their home. And again, we're saying we can say that we are supporting or we don't have enough evidence to support. Why? Because the claim was in the null hypothesis. So here's our steps for hypothesis testing. We're going to state the claim mathematically and verbally and identify the null and alternative hypothesis. We're going to specify the level of significance, usually that's given to you. We're going to determine the standardized sampling distribution and sketch its graph. That's going to usually be under a normal curve or a t-distribution curve. We're going to calculate our test statistic, whatever that is, and corresponding standardized test statistic, and we're going to add that to our sketch. We're going to find its probability, its p-value, and then we're going to use the decision rule. Is the p-value less than or equal to the level of significance? If our answer is yes, we're going to reject h sub 0. If it's no, then we're going to fail to reject h sub 0. We're going to write a statement to interpret the decision in the context of the original claim. All right, so an example. Writing hypothesis can depend on your position and what you're trying to prove. An inventor wants you to invest in their car company that their new gas engine gets mileage of 75 miles to the gallon. So how should I write my null and alternative hypothesis if the researcher wants to support the claim? So if we want to be able to write that we are in support of the claim, like we did here, support of the claim, we're going to want to put our claim in the alternative hypothesis. So for number 1, we're going to go h sub 0, h sub a. We're going to put our claim in the alternative hypothesis. So we're going to say that the mean gas mileage is greater than 75 miles per gallon. And so we'll say that our mean is greater than or greater than 70 miles per hour or 70 miles per gallon, 75, and that would make the null hypothesis less than or equal to 75. And then if we were trying to dispute the claim, all right, because we want to reject the claim, all right, we want to reject that claim, we're going to put it in the null hypothesis. So our H sub 0 would be that the mean is greater than or equal to 75, and then the alternative hypothesis, H sub A, would be less than 75. And again, that puts our claim here and our claim in that one for our alternative. Okay, so the last thing I want to talk about is how to determine the test tail types. The tailedness, and that's a Macaulay word, of the hypothesis test is determined by the inequality in the alternative hypothesis. So the HA or the H1 inequality is the one that we're going to be talking about. Now, in all of my instances here, mu is a stand-in for any value tested by the hypothesis test. And you can test either standard deviation, the population proportion, or the population mean. And also note that K is a stand-in for whatever value were discussed in the hypothesis test. And just to real quick go back to the last one we did, the K in this particular instance would have been 75 miles to the gallon. So I want to go through the three types of tail test types. And so we have this little diagram here. And so a right tail test is going to be when the null hypothesis mu is less than or equal to K, and the alternative hypothesis is going to be when mu is greater than or equal to K. And so when we look at this thing, when you have your p-value that is smaller than your alpha level, we are going to say that H sub A is going to be the more probable value. And so how do I determine it is based upon this particular statement right here. H sub A is mu greater than K. All right, and so you can kind of think of it this way. The arrow is pointing to the right. So the arrow is pointing to the right. The left tail test is going to be similar, except we're going to have the values flipped a little bit here. And so again, when you see that the mu is less than or equal to K, the arrow points to the left, talking about a left tail test. Now in each instance, if we want to find the p-value, it's going to be the normal CDF of the z-value to infinity. And again, we don't use infinity, we just put it there. We use that 10,000 or some large multiple of the standard deviation. 0 and 1 because it is the standard normal curve. And then for the left tail test, we start at negative infinity, go to the negative z-value, and again, that's in quotes because most likely your z-value will be less than 0 in a left tail test. But that's not always going to be true. And then a two-tail test, when H sub A is mu is not equal to K, we're going to split that into half. And so the p-value, or half of the p-value, will be the normal CDF of negative infinity to z from here to there, or it'll be half the half of the p-value will be the normal CDF from the z-value to positive infinity, with 0 and 1 being your mean and your standard deviation. Well, that's all I got for today, folks. So our Marvel fun fact of the day: the original Guardians of the Galaxy movie, it took Dave Bautista 3 to 5 hours to get into the Drax makeup. For the sequel, the process was improved to only last 90 minutes. Well, that's all I got. Have a good day. Goodbye.